Solve P equals 2L plus 2W for W. Here we have an equation that has more than one variable in it, and this is a formula. You may have seen it before. This is actually the formula for the perimeter of a rectangle. A rectangle is a four-sided shape with four right angles, with a length and a width. And one true fact about rectangles is that the opposite sides are equal to each other. So the length is the same on the top and bottom, and the width is the same on the left and the right. And the perimeter is the distance around, all the way around the outside of a shape. So if we were to start at the bottom left corner and work our way around, as we go to the right, we move L units. So that's L. And then plus, as we move upward, that's W units. So L plus W. And then as we move to the left, that's another L. And then as we move down, that's another W. So L plus W plus L plus W. And if we combine like terms on the right-hand side, L plus L is 2L, and W plus W is 2W. So we end up with P equals 2L plus 2W, and this is the formula for the perimeter of a rectangle. Now, a formula is basically an equation that gives a relationship between two or more quantities. This gives us a relationship between the perimeter, the length, and the width. If we want to find the perimeter, we need to take twice the length and twice the width and add them together. Now, we were given this formula as it is, but we're asked to solve it for W. What that means is we want to get W alone on one side, kind of like P is now, but we want to get W alone, and we want to have W written in terms of the other variables, P and L. So our goal here is to get W by itself. Now we see that W is on the right-hand side. We've got this 2W term. There's another term, 2L, that doesn't have a W, so we want to get rid of that, and we're going to eliminate that on the right-hand side by subtracting 2L on both sides. When we do that on the right, we're just left with 2W because the L terms cancel out. Now on the left, P minus 2L is just P minus 2L. Those aren't like terms, so we can't combine them. If we want to do the subtraction, we have to write out P minus 2L. Now we've got W almost alone, but there's a 2 in front of it. To get rid of that 2, we need to divide both sides by 2. And when we do that, we have W on the right and P minus 2L all over 2 on the left. And we have solved for W in terms of P and L. W is P minus 2L over 2. There is another way that we could do this that would give us an equivalent answer. If we instead, when we divided by 2, divided each term individually by 2. Gives us something that looks a little bit different. So here I'm still dividing by 2, but instead of taking the P minus 2L and just shoving a 2 underneath, I'm taking each term individually and dividing them by 2. Also a perfectly acceptable way to do this. Now P divided by 2 is just P over 2. We can't reduce that fraction. But the second term, 2L divided by 2, is just L. The 2's cancel in the numerator and denominator. And then on the right, the 2's cancel again, and we're left with W. So another way of writing this is P over 2 minus L equals W. And these two answers are what we call equivalent. They may look different, but they express the same relationship. And so either of these would be a correct answer. You may find when you're solving formulas that you might get one answer and a friend might get another answer and they look different, but that doesn't necessarily mean that anyone is wrong. It's possible to have multiple answers that look different but end up being equivalent. So in this case, either of these is the correct answer. I do want to say just a couple more things. First, you have to be careful, especially with online homework systems. If you're given a formula where P is capital, you've got to make sure P is capital in the answer. And if there are variables that are lowercase in the formula, they have to stay lowercase in the answer. Online homework systems are case sensitive. So if you take a capital variable and make it lowercase or vice versa, it will mark your answer as wrong. And for good reason. There are some formulas that include capital and lowercase letters. You might have a formula with a capital R and a lowercase r, and those refer to a larger radius and a smaller radius. And if you mix those two up, then you're confusing two different quantities. So it's important that our variables remain the same case that they started. And then the other thing I want to say about this is why it's helpful to solve a formula for a variable. The original formula was solved for P. P was the variable that was alone. And this tells us how to find the perimeter if we know the length and the width. But when we rearrange things and solve for W, this tells us how to find the width in terms of the perimeter and the length. Suppose we're making a garden and we have so much fence for the perimeter, and then we know the length has to be a certain length, and we want to figure out how much width there is space for with the fencing. We would take the perimeter and then subtract twice the length, and if you divide that by 2, it tells you what width you're able to make your garden. So it's very useful in different circumstances to take one formula but solve it for a different variable, because a different situation might want us to be figuring out the value of a different variable.